Hi everyone, I am Rajitha, working as an Assistant Professor of Artificial Intelligence and Data Science Department in SNS College of Engineering. Today we are going to discuss about logistic regression. Logistic regression is a supervised machine learning algorithm designed to solve classification problem, especially those involving two possible outcomes. Unlike linear regression that predicts continuous values, logistic regressions estimate the likelihood or probability of a certain event happening. It outputs a probability between 0 and 1, which is then used to assign a binary class label based on a defined threshold, commonly 0.5. For example, if the probability predicted by the model is greater than 0.5, the output is labeled as 1. This method is particularly useful in cases where we want to know the presence or absence of a condition, such as whether a patient has a disease or not, whether a transaction is fraudulent or not, or whether an email is spam. Logistic regression is widely used in industries like healthcare, banking and marketing due to its interpretability and simplicity. It models the relationship between a set of independent variables and a dependent binary variable by using a logistic function to ensure output remains between 0 and 1. Its transparency and ease of understanding make it an ideal choice for real world application where explanation is important. Applications of logistic regression. Logistic regression is commonly used in several real-time domains in the healthcare sector. It is employed to predict the risk of disease such as diabetics and heart conditions. One notable use in the Framingham Heart Study, which used logistic regression to identify risk factor for heart disease. These models have proven to be quite accurate, with prediction accuracies ranking between 72% and 78%. In the field of finance, logistic regression is instrumental in assessing credit risk, such as determining if a person is likely to repay a loan system like FIGO scores, scoring relay, or on logistic regression to calculate credit worthiness. The finance industry has also used it to reduce fraud losses. In 2023, financial institutions reported a 20% reduction in fraud related losses due to the adoption of logistic model. Meanwhile, in marketing, logistic regression helps business predict customer behavior such as churn and conversions. This kind of predictive modeling allows business to develop targeted marketing strategies, resulting in increased efficiency and cost saving. Logistic regression models have helped some organizations improve conversion rates by up to 15%. The logistic function. The logistic function. At the heart of logistic regression is a logistic or sigmoid function, which is used to make any important value score between 0 and 1. The sigmoid function is defined mathematically as p equal to 1 by 1 plus e power minus z. Here z is the weighted sum of the inputs calculated similarly to a linear equation, where each feature is multiplied by a corresponding weight and added together. The exponential component in the function ensures that no matter how large or small z, the final result stays between 0 and 1. When z is a large positive number, the output of the sigmoid function approaches 1, indicating a high probability of the event occurring. When z is a large negative number, the function approaches 0, indicating a low probability. The midpoint of the function where z equals 0 gives a probability of 0.5, which is usually the decision threshold. The smooth S-shaped curve is what makes logistic regression ideal for binary classification problems. It not only gives us the predicted class but also tells us how confident the model is in its prediction. How logistic regression works. It's a data preparation, model training and prediction. And the assumption of logistic regression is a binary dependent variable, errors are independent, and log odds linearly related to predictor, no multicollinearity among predictors. And the evaluation metrics accurate and precision, and evaluating metrics is accuracy, precision, recall, and F score. And the evaluation metrics is ROC and AUC. To further understand model performance, especially for classification, the receiver's operating characteristic curve and the area under the curve AUC metrics are used. The ROC curve plots the true positive rate against the false positive rate at various threshold level. A good model will have a curve that bows sharply toward the top left corner of the plot, indicating high true positive rate and low false positive rate. The AOC quantifies the entire two-dimensional area under the ROC curve. A model with an AUC of 1.0 is perfect. It predicts all classes correctly. A model with an AUC of 0.5 performs no better than random guessing. Therefore, the higher the AUC, the better the model is at distinction between the two classes. These metrics are particularly useful when the classes are imbalanced, and other metrics like accuracy might be misleading. ROC and AUC provide a graphical and numerical method to judge how effective the model is at separating classes across different thresholds. And the summary is that the logistic regression is a powerful yet interpretable algorithm that is widely used for binary classification tasks. Its applications span across healthcare, finance, marketing, and many other fields. What sets it apart is its ability to provide not only prediction but also the probability and reasoning behind those predictions. Evaluation metrics like accuracy, precision, recall, F1 score. ROC and AUC ensure the model's prediction trustworthy and actionable. However, logistic regression does rely on certain assumptions such as independence of observation and a binary dependent variable. Preparing high quality data and ensuring these assumptions are satisfied is crucial for getting meaningful results. Despite being simple, logistic regression remains a strong choice for classification problems because of its transparency, reliability, and ease of use. Thank you.